So, development and testing, really, really simple. We're just going to be comparing stuff, alpha to beta, and black box to white box, and then we also go through some test data and basically identify what a test plan is. Most of it's really simple and actually kind of obvious once you know what each part of it means. So, before we get started, development and implementation are kind of, they've shared them. So they're both used quite often and one replaces the other in various places. So if you ever see implementation or development, you know what you're talking about is going to be this area of the system's life cycle. So we call the first part we're going to go through test data, and basically this follows validation rules. It's kind of like when you use a database and you make sure that you don't put in the wrong number. Well, this is what happens afterwards to make sure that we've tested it, to make sure that it only accepts the right answer. So this is what a test plan might look like. So let's say that you guys have done a test and you've got 80 out of 100 is going to be an A, 70 a B, 60 so on and so forth. Now all you would need to do for this part is, let's just make it a bit bigger, there we go. For the normal and valid part, you would do a test where you'd make sure it's between 0 and 100 because the test is out of 100. So you could do 30, we could do 75. The expected outcome for 30 would be a fail, but the test would be a success. The test would work. Okay, so it would still be able to run through the program without breaking, and it would give us an expected outcome, i.e. it should say fail. So maybe if I put that inside speech marks. There we go. Now if we got 75, then they should get a B. So it should output a B and the program should run through. So the program should run. Okay, so the next part is abnormal or invalid. Now again, these are like two words that are interchanged all the time. So abnormal, we're looking at like, 300. That should give us an error, program shouldn't run. And also if we put in something like, I don't know, hey, again, it should give us an error, it shouldn't run. So they're invalid inputs, and this is where a lot of kids get really, really confused, more so in computer science because we don't really touch on this too much. But basically when we've got extreme, we mean extreme valid. So it might be 99 and the other test would be 1. So they're both still acceptable, but they're right on the extreme limit of acceptance. So accepted, oops, forgotten how to spell accepted. And this would give us an A, or you guys would probably be hoping for an A star for that. And then this would probably be a U, but it would be an accepted program and it would run. Sometimes, yeah?
So wouldn't extreme be 100 and 0?
Yeah, it would. What we're looking for is something right on the limit. So 100 could be it. 99 you'd also definitely get accepted. But yeah, it's right on the very limit. Yeah, you're right. But yeah, good question. You also do sometimes get extreme invalid. So that would be like 300,000 and minus 300,000 or something similar to that. Rarely comes up though. Usually they just stick to those three. And that is literally all there is to test data. Most of the time in a test you will get asked to make a test data table like this. So guess what you're going to be doing is exactly that. Now I'm actually going to run through the whole of this because I've only got 3 more slides and one of them doesn't really count because it's tiny. So we're going to move on to alpha and beta testing. Now I'm going to try and help you remember this in a specific way. So alpha testing, alpha is like top dog. So top tier or the best, and what I mean by that is we have specialists that are trying to find errors and then retest again and again and again and again and again. Now if you've ever wanted to become a game maker or a programmer or anything like that, then testing is the bane of your life. So let's say you find a glitch in a game. You have to keep going again and again and again and again to find that glitch, or well, if you fixed it, then hopefully you fixed it, but you still have to test again and again and again to find that glitch. If you find the glitch once, you have to try and we find that glitch. So you'll be going back through that game again and again. This is the same for alpha testing. When we're doing general programs, we might test one specific module and go through that again and again and again and again to make sure it works perfectly, and the person who wrote that module is probably the person that's going to be testing it, so a specialist. Beta testing is a little bit different. You might have even seen when you've downloaded something, it says like, I don't know, Google Meets beta, and it'll say BETA next to it. That means it's a test version, but it's been available to the public, and the whole time that you're doing something on that test version, it will be sending stuff back to, say, Google or whatever company makes it. So usually it's a customer testing out the whole system, and this is usually when they're very ready for the program to be sent out to everyone. That's literally the difference between alpha testing and beta. So one of them's specialist, one of them's generic customer testing on the whole program. Black box, white box. This one's also really, really simple. So black box, you can't see inside it because the box is black. Mental, right? So this is basically a blind test. So you'll be testing the whole program or the product. You won't know the code behind the scenes. You can kind of see how this could be interchangeable with beta testing, so it's really, really similar. Can't see inside it, you can't see the code. You're probably not a specialist programmer or anything like that. You might just be a user who's being paid to test the program. White box testing probably should be called transparent, as in transparent box, because you can see the code and everything behind the scenes, and this is broken down into small modules. There's usually a programmer or a specialist designer that goes through and tests each part. That's all there is to black box, white box, alpha, beta, and test plans. Test data. The only other thing that you have to do, or you have to know about, are test plans. So test plans are usually done before we actually implement or put out our program, and it makes sure that we're testing on stuff that we agreed upon at the start. This means that if our user or our client wants us to build a program with certain specific things, we're testing for those certain specific things when we've made the program. The idea is that our user or our client doesn't randomly start adding loads and loads of things, because obviously that would take up loads of time, loads of money. So what we want is at the very start, we agree on everything. This is what we need to do, this is what we're being tested on, and that's it. So it should identify the tests for every single element of the program that we've made, or the software, or anything like that. So that's all there is to it. You'll notice I didn't go through a test plan slide, and that's because it's part of the, not to make a slide, but it's part of the questions, is basically what I've just said. So I'm going to get you guys now to go to Google Classroom and answer the question sheet. I'm going to stop this now. Goodbye.